This video is about solving rational equations by setting the numerators equal to each other. We'll also talk about extraneous solutions that can arise when solving rational equations. Let's get started. As a reminder, a solution to an equation is a value of the variable, usually x, which results in a true number sentence. Okay, this is true for any kind of an equation. Okay, whenever we solve an equation, we're looking for the value or values of our variable that makes the equation true. In this video, we're talking about solving rational equations where we typically have our variables in the numerators and denominators of our rational expressions. In number 1, what number divided by 5 minus 2 divided by 5 is equal to 1? Well, the denominators are all the same. There's a common denominator, and so I can focus specifically on these numerators and ask myself, well, what number minus 2 is equal to 1? Okay, because when this is true, then my original equation is also true. Okay, and I can solve this very easily and know that x is equal to 3. Okay, and plug it back in just to check that 3/5 minus 2/5 will give me 1/5, and this is the actual solution. Okay, this method is what we call, equating numerators, or once you have a common denominator, you then set the numerators equal to 0. So what might it look like if the denominators are not the same, like in number 2? Well, I first find a common denominator. The common denominator between 2, 3, and 6 is the number 6. So I can multiply top and bottom here by 3, top and bottom here by 2, and leave that the same. So I get 3x over 6 plus 2 over 6 is equal to 5 over 6. Again, I have a common denominator, so I can focus on these numerators and ask myself, when is 3x plus 2 equal to 5? Well, if I solve this equation, I get 1. Okay, so is that true? Is 1/2 plus 1/3 equal to 5/6? And it is. Okay, that is the method we're focusing on, but in much more complicated rational equations. Okay, before we do that, let me talk to you about what could arise when solving rational equations. Okay, you could get extraneous solutions. Okay, an invalid solution that may arise when we manipulate a rational expression is called an extraneous solution. An extraneous solution is a value that satisfied a transformed equation. So for example, if I look at just the numerators, that's a transformed equation, okay? But invalidates the original equation, okay? So as you transform the equation, it comes out algebraically, but if you plug it back in the original equation, it no longer is true. Values that appear to be a solution to the equation but cause division by 0 and are thus not valid. Okay? The problem that could arise from rational equations is a problem where we're dividing by 0. Let me explain really quickly why we can't divide by 0. Okay? If you have a question like, what is 6 divided by 2? You have 6 things. You're putting them in groups of size 2, and you have 3 groups. Okay? If you have 0 things, right, and putting it into 2 groups, you have 0 and 0. That's fine. Okay? What becomes weird is if you have 6 things and you put them into 0 groups, then how big is each group? Well, I still have 6 things, and I'm not putting them in any groups, and so that doesn't make sense. This is undefined. Okay, and so we can't divide by 0. So when solving, we will always check for extraneous solutions. and I do that at the end of the problem. Okay, so with that in mind, let's solve some rational equations. Okay, and this is a method where we'll find a common denominator and set the numerators equal to each other and solve. Okay, let's do letter A. All right, so I have 3 over x is equal to 8 over x minus 2. Okay, and so I'll find a common denominator the same way that I did when adding and subtracting. Okay, I ask myself, what does this denominator have that this one doesn't? Well, and I think about x minus 2, the whole thing as a factor. Okay, I cannot subtract 2 from top and bottom. That would change the value of the fraction. Okay, so I have to multiply by x minus 2 and x minus 2. Okay, and similarly, what does this denominator have that this one doesn't? And it's this x. So multiply this times x and this times x. Okay, and let's rewrite it. So I have 3 times x minus 2 divided by x times x minus 2 is equal to 8x divided by x times x minus 2. Okay, so I have the exact same denominator. I have x times x minus 2. So I can focus on just the numerators, and when are the numerators equal to each other? So let's write that down. So I'm looking focused on 3 times x minus 2. When does that equal 8x? Well, I will distribute this 3 and get 3x minus 6 equals 8x. Okay, I will then, let's see here, get my x's together. This is linear, so I'll subtract 3x from both sides, and I have negative 6 is equal to 5x. Okay, and then I will divide both sides by 5, and I get x is equal to negative 6/5. Now, before I start celebrating and think I'm done, I will double check that if I plug this back in here, do I get any division by 0 problems? The answer is no. Okay, that only happens when x is 0 or x is 2, and I don't have either of those as my solution, and so x is equal to negative 6/5 is the solution to my equation. Okay, that's when it's true. The next one I want to try is number 2. Okay, the first thing that I'll do is I will factor all the denominators. Okay, the first 2 terms are totally fine. This a squared minus 4 is the difference of squares, which becomes a, and I have 2 and 2 and plus and minus. Okay, that is my least common denominator. Okay, so I then ask the very important question of, what do these denominators have that this one doesn't? And the answer is an a minus 2. A minus 2. Okay, and what do these have that this one doesn't? And it's the a plus 2. Okay, and then what do these have that this one doesn't? And the answer is nothing. It has everything. Let me rewrite this so it's not so cluttered. So I have the very first term is a minus 2 divided by a minus 2 times a plus 2, plus I have a plus 2 divided by a minus 2, a plus 2, is equal to 4 divided by, I'm going to switch these around so it's the exact same as the others, a minus 2, a plus 2. Okay, so I now have a common denominator, and I will focus on the numerators. Okay, when is this true? Okay, because when that is true, then this equation will also be true. So, when is a minus 2 plus a plus 2 equal to 4? Well, if I combine like terms, a plus a is 2a. Negative 2 plus 2, those cancel, equals 4. Well, divide by 2, and I get a equals 2. Now, before I celebrate, let me double check that I don't have extraneous solutions, and I'll plug this back in the original equation and see if I get any division by 0 problems. Okay, in the first term I'm dividing by 2 plus 2, which is 4, and that's fine. If I plug it in here, then I get 2 minus 2, which is 0, and that gives me division by 0. Okay, and also similarly here, I get 2 squared is 4 minus 4, you again get division by 0. So this cannot be my solution. Okay, so I get no solution. If this was going to work anywhere, it was going to work at a is equal to 2. But it can't work there because that gives me division by 0, and so there is no solution, there is no a value where this equation is true. All right, this equation is about solving rational equations by finding a common denominator and setting the numerators equal to each other. Thank you for watching.